Alright, welcome back to the next concept of expectation of a discrete random variable. In the previous video, we talked about the concept of mean average, right? So how does that actually relate to what we're going to learn right now, which is going to be a key concept that's going to keep repeating throughout this entire chapter. So let's just recap what we did previously, right? Which is rather straightforward. So we know that mean is basically the sum of all values over the number of values, right? And this is typically in the context of an experiment. So let's say I just reference the earlier example that we had. Referencing the earlier example we had over here, we can see that we have very specific data points, right? 80, 51, 72, 89, so on and so forth. So I want you to imagine that all of these are just outcomes of an experiment, right? And because we have outcomes of an experiment, we can basically put all the values of the outcomes. So for example, 80 plus 59 plus 87 plus ... over the number of values, right? So all of these individual values, since they are outcomes of an experiment, they are what we call the experimental approach. So this is an experimental approach to calculating mean, simply because the values that we use over here, right, they are the actual results from an experiment, so to speak, right? But in the concept or in the context of discrete random variables, earlier on we talked about the concept of probability distribution table, right? For example, let's say I let X be the number on the top face of a dice roll, right? And then we are assuming that this dice roll is unbiased, like, okay, it's just, so to speak, unbiased. So when we draw the table, we know that X over here can take on the values of 1, 2, 3, 4, 5, or 6, right? And then if I draw the table down like that, then we calculate the individual probabilities. So P X equals to X, right? We know that this probability is 1 over 6, 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 and 1 over 6. So with that said, all of these values over here, they are all possible outcomes of X, right? I'm just going to write it over here. They are all possible outcomes of X, right? All of them theoretically can be a possible outcome of X. But then the question is, right, since they are not the actual outcomes of X, right, what is the average outcome, or what is the outcome of X that we expect in the long run? So there's actually the concept of expectation, right? Since all these are the theoretical possible outcomes of X, right, each one of them, this is what we call the theoretical approach. Now, you don't need to know exactly what is experimental approach, what's theoretical approach, right? All the questions that you're going to be doing from this point onwards, they won't test you, oh, is this experimental approach or is this theoretical approach, right? It's not, this is trivial, but I need to go through this to actually branch whatever we know to what we're learning now. But don't worry, later you see the type of questions that come out, you will realize that it's actually very straightforward. So now the question that we want to ask ourselves, right, is that since all these are theoretical possible outcomes of X, then since they're theoretical, then what is the value of X that I can expect in the long run, right? Since I got 6 different possible outcomes, what is the outcome, or what's the value of X that I should be expecting if I roll the dice an infinitely amount of times, right? And that's basically what the expectation is. So I just want to go through a notation. So when we say expectation of a discrete random variable, so this is how we present it, right? Expectation, bracket, then the discrete random variable is inside. What we're trying to do over here is that we're trying to find out what is the expected value of X in the long run, or rather expected value of X if I repeat the same experiment infinitely amount of times. That's the whole idea behind it, okay? And how do we calculate it? The way that we calculate it is using this formula over here. I'm going to give you the formula at the end, but it's taking each possible outcome and multiplying it with its associated probability. So for example, for a value of 1, right, the probability is 1 over 6. And then for the value of 2, the probability is 1 over 6, right? And then for 3, the probability is 1 over 6. And then for 4, the probability is 1 over 6. And then for 5, the probability is 1 over 6. And then for 6, the probability is 1 over 6 over here. By multiplying each possible outcome with its associated probability, we are able to find what is the expected value that we can get in the long run. And you realize that the expected value that we will get is 3.5, right? So that is the expected value of X if we do it infinitely amount of times. But for each time you roll, of course, you'll get either one of these values over here, 2, 3, 4, 5, 6, right? Either one of them. But if you keep doing this experiment infinitely number of times, the expected value that you get at the end is 3.5, right? And that's the whole idea behind it, which is what is the expected average value of x. Okay, I just got to put a caveat, average, right? Because you repeat the experiment many times. So averagely speaking, what's the value that we can expect? So that's the whole idea behind it. And actually there's a formula for this. If you realize, what we did was we sum all of the individual values of x with the associated probability. So the formula is just taking the sum of all the values of x multiply with its associated probability, and then we just sum them all together. So you see x over here is the actual value of x itself, multiply with its associated probability, and then we sum for every single use case over here, right? That's the whole idea behind it. Okay, so that's the concept. Feel free to pause this video when you need to revise, go back and rewatch any part that you need. If not, we're going to try to tackle the question right now. So this is the question that we're going to tackle together. Feel free to pause this video right now to watch this, to actually attempt this question. And when you're ready, come back, return, and we'll begin doing this question right now. Okay, so this should be a fairly straightforward example over here. We are supposed to find the expectation, which is the average outcome or the average value of x in the long run, right? And for this over here, if you recall, the formula is the summation of all the individual values of x that you could take on, multiplied with their associated probability, right? And it makes sense, right? Because when you have 6 different values and each time you roll a dice, right, the probability of each of the values is as such in the table, right? You can basically repeat the experiment many times, and in each experiment the probability remains the same, right? And we know that this is a lot of assumptions going on. That's why this is called the theoretical approach, right? Because we are assuming that the probability remains the same, right? And we can do this like infinitely number of times, which no one wants to do this like so many times, right? But this over here, when you roll a dice, or in this case, yeah, you have a 6 different values, and then you repeat this experiment many times. Over the long period of time, the probability associated with each value is basically the frequency in which they will appear, right? So for example, if you see x equals to 1 has a probability of 0.05, right? If you roll these dice 100 times, the number of times that you can expect 1 to appear will be 5, right? Because there's a probability of 0.05. So when we do this many times, the probability associated with each value, becomes the frequency in which they occur. That's the whole idea behind it. Okay, so that's why this formula is as such. And using the formula, applying the formula is actually very simple from here onwards. It's just taking 1 multiplied by 0.05, 2 times 0.3, 3 times 0.15, 4 times 0.15, and then 5 0.3, and then 6 0.05. Right, just sum all of them up together, and eventually you get a value of 3.5, and that's the final answer to this question over here. Okay, let me know if you got any other questions in the comments. Otherwise, I'll see you in the next video for the next concept that we will be going through, which is the discrete. We'll be basically just going through the function in the next concept. Okay, and I'll see you there.